Hello, everybody. Welcome to today's episode of the Golden Path to Spring One. I'm very excited today. We're going to be talking about Spring Cloud Function. I know that Oleg gave us a preview of the code that he's going to be demoing, or the part that he's going to be showing you, and it's very little code and it's very powerful, which is a combination that I always find extremely amazing. So with that, I want to welcome Mark Sales and Oleg Zurkowski to the stream. How are you guys doing?
We're good.
Yeah, fantastic. Awesome. Thank you.
Where are you guys joining us from?
Mark?
I'm in Leeds in the UK.
And I'm south of France.
In the south of France? In the south of France? Anyway, whereabouts? How far down the south of France are you?
I'm in Antibes.
Okay.
Just by the coast.
Oh, beautiful.
Coastal town, yeah.
Wonderful. Okay, well, everybody who's in chat, welcome to everybody who's joining us again. We have people. Thank you, JR. JR is saying great content, great channel. Thank you, JR, for that. We appreciate it. And so I'm going to hand the stage over soon, but I just wanted to ask you guys, you mentioned earlier that you've been working together for quite a while, but you haven't met in person yet. So I was curious about maybe if you could share with us a little bit about how you came to work on this project together and what are the possibilities that you might actually meet one day?
Well, as far as why we haven't met, COVID had something to do with that. So, we have presented together actually several years ago at Spring One, the virtual one, on a similar topic, but it was way too early it was way before what we're going to be showing today. But yeah, and now finally we have a very good chance to meet face to face because the topic we're going to be presenting today was selected to be highlighted as one of the segments on this year's keynote at the VMware Explorer. So finally, Mark and I will meet.
Wow.
Yep.
Yeah, after 2 years of chatting on Slack about bug fixes and feature improvements, yeah, it'd be good to meet in person.
Amazing. Well, congratulations on being selected for keynote, and we'll be sharing information about Spring One in Vegas at the end of this presentation. But for any of you, if you can join us in person there, I will also be there and would love to meet all of the folks who've been joining us in this series. So with that, I'll turn the stage over to you guys. So if you want to share your screen, whichever screen needs to be shared.
All right, I'll be sharing the screen. I'll be the only one sharing the screen. And
sorry, that was me. Oh,
that's right. I looked at my phone immediately.
Stop all those things in a second. Yeah, I forgot.
Okay. I'm going to switch to slideshow. So today, what we're going to talk about, so we're going to have slides, we're going to have a few demos, and we're going to have some code. So as far as the questions, we've been discussing how we're going to handle with the questions. So we asked Cora to help us out with that in terms of if there's any questions coming in, she will let us know, and we'll determine whether we can answer it right away, or we can postpone it towards the end of the discussion.
I'm actually going to pop off the screen to give you guys the full time. So if there are questions, I'll pop back on. But otherwise, the stage.
All right. Just last question, Cora. Yeah. Can you see my slide deck right now perfectly?
Yeah, it looks perfect.
Okay, good.
Beautiful.
So today, Mark and I are going to be talking about. I would say kind of not a conclusion, but a good milestone of our 2-year collaboration on many different subjects related to the framework that I work on for the past couple of years, which is Spring Cloud Function. And Mark will obviously explain what he does for AWS, but it's been very productive partnership, and I'm pretty happy that we can present the content that we're going to be presenting today, as well as what we're going to be doing at the keynote and a breakout session in Vegas. So today we're going to talk about Spring Cloud Function and AWS Lambda, sort of performance, portability, and productivity. Try to cover all of these subjects. Quickly about myself, my name is Oleg Zurkowski. I work for Spring I would say I'm an old-timer. I've been with Spring since about 2008. I left for a little bit, but then came back. We always do. So, and right now I'm a project lead for Spring Cloud Function and Spring Cloud Stream project. And Mark?
Yes, so my name is Mark Sales. I work for AWS, and at AWS I'm a solutions architect. So I work with our customers at AWS to help them build serverless solutions predominantly. That's where I specialize in. And within those services, I have a particular interest in Java and a particular interest in Lambda. And as a professional, I've been programming in Java like all my career. So it's something that really resonated with me when I was at university. And then ever since I've been a professional programmer, I've been using Spring. So it's something that, it's been fantastic to continue to work on now that I'm at AWS, and I've been at AWS for 5 years now. And it's cool to see the partnership grow and work together closely with Oleg.
Thank you, Mark. So today, agenda. So we're going to be basically interacting, Mark and I. I'm going to talk a little bit about Spring Cloud Function. Mark will cover a little bit about AWS Lambda, and then we're sort of going to bring everything together. And then we're going to talk about, I wouldn't call it a new feature, but as of today, something important happened. We kind of merged our efforts together. And right now, this ability to run web-based workload on AWS Lambda is something that's very interesting and very useful for a lot of users. And right now, with our partnership, we now working together on this effort as opposed to just delegating it to AWS. So we're going to talk about that as well. So without further ado, Spring Cloud Function. So as I'm going to assume that people who are listening right now are somewhat seasoned Spring users, and as seasoned Spring users, you are aware that Spring has always been about productivity, about improving the productivity for a typical Java developer. And with every framework, we're trying to address a particular issue, particular problem, and make it easier to work with by defining certain abstractions, certain idiomatic ways of programming to make sure that your code stay consistent and sort of bug-free and easy to read, easy to understand, and easy to maintain. So, and the same is with Spring Cloud Function. So Spring Cloud Function is improving your productivity by promoting the development of your business requirements using Java functions. When I say Java functions, I'm implying the Java 8 functions that came, the Java functions that came with Java 8, which is a supplier function and consumer, which is a interfaces provided by the core Java framework. So with Spring Cloud Function promotes development of these requirements by promotes the development of business requirements by asking you to write Java functions, while the framework itself will now instrument those functions and make them execute without any code change within the various different execution contexts. So imagine you have Java functions that all of a sudden, with just adding a dependency to the class path, becomes a message handler or REST endpoint or AWS Lambda, as we're going to see today, and so many other things. So again, in summary, Spring Cloud Function is a Spring Boot-based framework, promotes the use of Java functions to implement business requirements, and then instruments these functions within a supported execution context. Like I already described, your function could be pretty much anything that we support today, and if not, we can support it later, or you can, based on Spring Cloud Function abstractions, you can implement your own support for Java functions within your particular runtime. And as I said, we're going to have some demos. So right now is the time for the very first demo. Very simple demo, just to show you what kind of give you the feel for what Spring Cloud Function is. So as you can see on my screen, like I said, my code is going to be very trivial today. The reason for that is that, like I said, the emphasis here is on the function itself, not basically its signature, not what it does internally. It could be as simple as this, uppercasing the string, or as complex as sending rockets to Mars. I mean, it doesn't really matter to the framework, because the framework goal is to look at this function and represent it as either a message handler, a REST endpoint, or AWS Lambda, or RSocket handler, or anything like this, right? Like gRPC, we support many different triggers. So in this case, what you see is another interesting thing about Spring Cloud Function is it's very hard to say what this application, it's very hard to describe this application by just looking at the code, because by just looking at the code, all you see that it's a Spring Boot app and it has a function bean in it, nothing else, right? So the only way for us to see exactly what this application may do, we need to look at the POM file. As you are familiar, so with the Spring Boot, we got this concept of where the dependency are not just libraries, not just binary dependency, they're also auto configuration. So when we bring a dependency like I'm going to bring right now, we not just bringing some kind of a binary dependency on some classes and so on, we also bring in auto configuration. So in this case, what I did is I'm bringing Spring Cloud Stream binder rabbit, which is from another framework that I manage, which is Spring Cloud Stream, which is basically going to represent, which will instrument this function to be a stream handler, which means that I can send the message to RabbitMQ, and by sending that message, it will trigger invocation of that function, as well as I'm bringing Spring Cloud Function Web, which will also represent this function as a REST endpoint, all by just bringing that as a dependency. So let's see how that works. I'm going to start it. It all started. You can see that the server started on port 8080, and now I can do something with it. So first thing I'm going to do is I'm going to go to RabbitMQ, and you can see the uppercase destination was created, so I can publish message, hello all, publish message. I go to the console, and you can see the message uppercasing hello all. I can also go to localhost, uppercase Oleg, and now Oleg is uppercased, and I can change it to Mark, and now Mark is uppercased. Okay, so it's really that simple. You bring you write your function. Again, you can write many functions, so I'm just showing you one function, but you can write many functions, and they don't have to be strings. It could be POJUs, could be anything, because within Spring Cloud Function, we provide transparent tab conversion, composition, and many other features, which is kind of out of scope for us to cover today, but there are other presentations that are now recorded from different other conferences where you can get more details on Spring Cloud Function in terms of the actual nitty-gritty details. Okay, back to the slides. So now I'll let Mark to talk about, so like I said before, we're going to talk about function, we're going to talk about Lambda, then we're going to bring everything together. So now I'm going to let Mark to talk a little bit about AWS Lambda and what to do with it.
Cool. If you don't mind, Oleg, if you could just full screen that, that would be awesome.
Sorry.
So yeah, it's really interesting to hear Oleg talk about Spring, and Spring being this framework which helps deliver productivity to developers, because that's basically how I feel about AWS Lambda. I feel like over the last few years, there has been this evolution of computing with cloud computing, where more of the service and more of the management of the service is handled by a cloud provider. And AWS in particular has really innovated in this area, I think. So, you know, at the bottom left, we're looking at physical machines, which you might have been used to using. You know, in the start of my career, I can remember, you know, discussing like what machines we were going to buy and what hardware we were going to need to run applications. And that was kind of scary because we're talking about months waiting for stuff to arrive and getting it put into data centers. And then we moved on to using virtual machines, and you know, having to discuss how many virtual machines you could take from a certain allocation for a department. And then, the huge evolution and popularity of container platforms and Docker and the various platforms, and the fantastic capabilities of Kubernetes now is amazing. But right at the top right, we're talking about serverless services. So in particular, we're going to be talking about AWS Lambda today, but also AWS Fargate as a serverless compute platform for ECS, which is our Elastic Container Service. So we feel like this is an evolution because AWS Lambda gives you even more of a managed service. So some of the particular key characteristics of Lambda, which I think is really beneficial, is the automatic scaling. So with other platforms, you may set up automatic auto scaling, but you're provisioning with quite large chunks of compute, and basically there's a complex algorithm of how fast could your service scale, which then depends on how much spare headroom you need, and all of that is pretty painful to work with if you've got high performing systems and you don't want to have periods of less than ideal performance. Okay, so Lambda scales automatically with traffic throughput. It also has built-in fault tolerance from the beginning. So as soon as you create a Lambda function, that Lambda function is going to be available across all of the availability zones of that region. And you don't have to do anything special. It's just like that by default, which is fantastic. And further still, if there is any issues in any of the availability zones, that traffic will be moved away from that availability zone, and your traffic will go to an availability zone. So you have built-in fault tolerance and high availability. And maybe unlike other platforms with Lambda, you're actually only paying for what you use. Okay, so if your Lambda function is idle, you're not paying as a single cent. So you don't pay for idle operating system cycles or anything like that. So as your traffic increases, you pay per request. Maintenance is also a big hit. So with Lambda, patching of the operating system and the Java runtime is managed by AWS. So you no longer have to think about patches for operating system packages or the Java runtime itself. And I think that really resonates with a lot of people, and get back to focusing on what people want to do, which is write code and deliver business value rather than fiddling with servers. Cool. So if you could move on the next slide, Oleg.
It's funny how you mentioned you started from the physical machines, and I remember the same situations. And the funny thing is that by the time they finally decided and procured the machines and they arrived, they were already outdated because the requirements went up. And anyway, go ahead.
Yeah, so Lambda has a very similar model to Spring Cloud Functions, and this is why I think it fits really well. So when you interact with Lambda, you're not interacting with a server as such. You're not SSHing into a machine or accessing a specific IP address. The way you interact with Lambda is via an API. So probably one of the first things that you'll do is upload a zip file or a container image of your source code, not of your source code, of your application's class files, and then you will allocate one or more source triggers. And this could be anything from a HTTP request or a messaging system like ActiveMQ, RabbitMQ, Kafka, or any of our cloud native services like SQS or SNS or Kinesis. Or it could be on the fact of a change in state in a database, or the fact that someone's uploaded an object to S3. So lots of different ways to trigger your code. And then very similar to what Oleg was saying, you can you can program your Lambda function to do anything. So at that point, it's just running your Java code however you want to. So, you know, you
in a
can
way, the Lambda function stays static, like Spring function, yet you can attach many different triggers, invokers, whatever it is you want to call them, right?
Yeah. So, you know, your code can access your corporate databases, you know, other external APIs, you know, whatever you need to do in order to operate.
All right. Thank you, Mark. And so a little more about sort of mechanics of a Spring Cloud function. As I mentioned earlier, the goal of the frame, because it's like, okay, function is pure Java, so you don't need Spring or anything else to write a function. Of course you don't, right? So, and that's the beauty of it, because you write a pure Java functions, whether you decide within it to use Spring or not, or to use any other framework, that's entirely up to you. But then, by bringing auto configurations provided by Spring Cloud functions into the class path, which is actually also a very interesting topic, because when you're writing a Spring Cloud function framework, there is nothing in terms of code, you're not using like Spring Cloud function API or anything else, because it's really sort of sits behind the scenes, right? So you're only bringing a dependency, like I showed you earlier, and all of a sudden that function that you write becomes a REST endpoint or AWS Lambda or anything else. Because again, even in AWS Lambda, for those of you who have worked with AWS, you know that you have to implement like request stream handler or whatever other handlers provided by AWS, which means you have to know a little bit or a lot about the internals of a particular system, in this case, AWS, right? Or you can just write Java function, and all of a sudden that framework like Spring Cloud function will turn your function into AWS Lambda. So we do it by introducing sort of a wrapper over the function. So when you start up and you access your function, you're actually accessing a wrapped function, which is the wrapper adds all these additional features such as tab conversion, composition, routing, and the adapters provide the triggers for this function. So in other words, this function could now be triggered through a variety of different triggers. Sorry. Okay, so another demo. So this demo is going to be a little interesting to show, and I'm going to make it very sort of, we'll see how it goes. So first of all, what are we doing? So we're going to take that same, well, first of all, I'm just going to show you, go through the motion, but I'm not going to actually do a lot of things because we already deployed this into the AWS Lambda. So I'm going to comment this because we don't need really this, but you can see that there is also within this particular project, there's Spring Cloud function adapter AWS, which is auto configuration, which is responsible for turning this function into AWS Lambda. Okay, so and the project, so you'll see a link at the end of the last slide. We publish all the sample projects to the GitHub, so you can use them right away. So I showed you the POM, but what I didn't show you is the template YAML. So template YAML, this is basically a YAML file which is required by SAM, serverless application model provided by AWS. Mark, do you want to talk a little bit about what SAM is?
Yeah, sure. So Oleg could go into the AWS console and make loads of clicks and deploy a Lambda function. Okay, so he could follow all the console screens. Click
for example, what Mark is doing, telling what I'm doing right now.
Yeah, so he could go through all of the different screens and fill in all the boxes and select all the drop downs, or basically he could write this as an automated script. So we have a couple of different ways of doing this, and obviously there's open source alternatives as well. So you might be using something like CloudFormation or Terraform or CDK or Pulumi, and SAM is another infrastructure as code product, which is produced and maintained by AWS. And SAM stands for Serverless Application Model. So it is a set of infrastructure as code capabilities which are specifically designed for working with our serverless services, and it just makes things a little bit more simple and less lines of code by assuming sensible defaults. So Oleg was showing a template which basically defines all of the configuration for a AWS Lambda function, but also its events. So on line 26 and 27, it's defining a HTTP endpoint, which is going to be the trigger for his Lambda function.
Right.
And also on line 15, Oleg was talking about how the entry point of the Lambda function is probably not what you expect. So in this case, Oleg is calling the Spring library, which is going to do all of the work and set up the what's required to then call your code.
Right. And also just what Mark was describing, I've created a README file, so I'll explain in some level of detail everything right here, provide relevant links. And just as Mark pointed out to certain parts of the template file, I highlighted them here, the relevant parts of the file, so you can read more about it here, and as well as which commands to execute, like how to install them, how to install AWS CLI, and so on and so forth. Trust me, it's very simple. So basically now we have a command line. So for example, I will do, you just do sam build, sam build, and then I can do the same sam deploy and so on and so forth. But as I mentioned before, we already deployed it. So let's go into the function, and you can see the uppercase function has been deployed, and I can test it right away to show you, but I just decided like right this second, I'm not gonna do it. You'll see why I didn't do it right away in a few minutes, but we're gonna talk about something else, and then I'm gonna do the demo, and then everything will come together. Okay, so in other words, what I was trying to demo is that I'm gonna that I can invoke this function the same way I invoked it before using REST endpoint or RabbitMQ. So this way I can invoke this function via AWS Lambda, via API Gateway and everything else, and we'll do it in just a few minutes. So okay, Mark.
So one of the really interesting things about Lambda is I was saying that the Lambda execution model is quite different to a server. So when a request comes in, there is no server available to then service that request. So what happens is that we make what we call an execution environment, which is a virtual machine, basically just in time. So similar to just in time compilation, when you have traffic that's coming to a Lambda function, we're going to create an execution environment for that request by spinning up a virtual machine, downloading your code to that virtual machine, starting the Java runtime, loading your code into that runtime, and initializing any constructors, any static blocks, any Spring dependencies that you have. And then when that's all loaded, we're going to execute your code with the trigger that has been configured. And once that execution environment is ready, available, it's then going to process your request, and then it's going to stick around. So we're not just making one-off execution environments. We're going to keep it ready. And as your traffic increases, we're going to create more execution environments to meet the demand of the traffic of your API. So as long as your traffic is steady, we won't need to make any execution environments. If your traffic increases, we'll just keep making execution environments until we can satisfy the demand. So each execution environment handles one request at a time, and we just scale horizontally. So this is fantastic from an architectural point of view. Very low risk. It's very easy from a programming model point of view, so you don't really have to worry about thread contention or number of sockets open or garbage collection or anything like that. So the programming model is quite simple.
But I think what I like the most, sorry to interrupt you, Mark, I think what I enjoy the most working with Lambda is the fact that I really don't have to, I forgot last time I thought about infrastructure per se. I literally just, here's the code, and the only thing I ever had to worry about is how to invoke it. So of course, I'll show you in a second how to invoke it right from the dashboard just for testing purposes. But in reality, the HTTP API gateway or many other event handlers that Mark was alluding to earlier, that's the triggers to that function, or to that Lambda. But basically, that's the only thing you have to worry about as a developer. If all of a sudden you have 1,000 requests per second, the environment itself will scale up. And if you have nothing, it will scale down without really worrying about cluster topology, sitting in endless meetings to designing the cluster topology. How many servers do you need? Which type of servers do they have to be? How powerful or not powerful they have, and so on. So none of that has to be a concern from that point on.
Yeah, and while you have warm execution environments, you're not paying for those. You only pay for when your code is executing. So if you have a period of activity and then a period of less activity, you won't pay for any of the capacity that we're keeping ready for you in case that traffic comes back. But it does mean that occasionally we have to do more work to get an execution environment ready, and this is what you may see referred to as a cold start. Okay, so a cold start is just where we just have to do more work to get everything ready, and this is usually in the order of seconds.
Right.
So some of the things that influence cold start latency is some of the items in green are all things that are within AWS's responsibility. So, we're working hard to make sure that execution environments create really quickly, that we download your code as fast as possible, and we start the JVM in a reasonable way.
I think we can create execution environment a bit faster if we fix that spelling error.
Good spot. And then within the blue side is all kind of the things that as a programmer you can influence. So the more class loading that's happening, and the more kind of runtime work that's happening, will probably influence how much just-in-time compilation is happening. And those are the sort of things that influence cold start time. So when the JVM is loading bytecode and then compiling it to native, it's a big CPU spike and tends to affect latency. Yeah. So this is something that we at AWS are really interested in. You can just see that the same activity is being done thousands, millions of times. If you need a new execution environment, you're following the same steps each time, and it's basically overhead. So we were trying to think of a solution to this, and we've launched last year a new feature called Lambda Snapstart, and this just takes a completely new approach to creating execution environments. So Oleg will hopefully do a demo in a few minutes.
That's actually why I postponed, because you and I both know it's some of the things, I mean, they work, but some of the things are not very demo friendly, and they require a specific state of things to show you A and B sort of separately. And had I execute the uppercase function before, everything would work. Make no mistake about it, but the punchline wouldn't be as funny as it will be in a second.
Yeah. So the new feature, Lambda Snapstart, when you upload your function to AWS, you can click a single tick box, so to enable Snapstart, and then when you create a new function version, we're going to take your code and put it onto a separate worker which isn't receiving any customer traffic, and we're going to load your code into the JVM just like normal. We're going to execute any initialization code that you have. So constructors, static blocks, any of the Spring framework that you have configured, and then we're going to take a full snapshot of the entire virtual machine, and we're going to take that image and we're going to encrypt it. Then we're going to put it into storage, and we're also going to take that image and pull it into pieces and put it into a tiered low latency cache. And the reason we do that is that then any future execution environments that are created due to customer requests we're going to restore the snapshot instead of creating a new execution environment. And that turns out to be, orders of magnitude faster. So up to 10 times faster. So instead of getting a cold start of seconds, you're going to see cold starts of 500 milliseconds to a second, hopefully. And one of the cool things that you can do with Snapstart is that we've also allowed customers to have their own code run as hooks just before the snapshot is taken and just after the snapshot is restored. And the way that we do this is by implementing the CRAC APIs. So CRAC stands for Coordinated Restore at Checkpoint, and it's a project that I think is being suggested for inclusion in OpenJDK. And this is just an interface that you can implement to run code just before the snapshot to do any preparation stage, and then just after the restore to again prepare any functionality that you need after the snapshot is restored.
And again, with regards to Spring Code, we're already working hard on trying to provide sort of out-of-the-box default support for implementation of resource interface in terms that you don't have to really worry about for certain standard things like life cycles and so on and so forth to implement your own.
Yeah, and I put a link on the screen. This is a link to the Snapstart documentation page on for Lambda, and this will include a lot of further information. So if this is something that's interesting to you, there's only 4 or 5 additional pages on that link. I would really advise you to go read that. It won't take you very long. It's very interesting reading.
Likewise. All right, so now this is, we're going back to the demo, and now we're actually going to show you the demo. So, and I'll explain to you why I didn't show it to you from the very beginning. So the reason why is because Mark was just talking about the Snapstart, and what we wanted to do is we want to show you the actual difference between running something with a Snapstart or running something without a Snapstart, meaning that right now, while I deployed this function earlier today, I haven't touched it in probably 3 or 4 hours, right? Which means that according to, rule of common sense and what Mark was telling you for the past 30 minutes, how AWS will scale down or scale up automatically without you touching it, this function should be idling right now. It should be sort of suspended, should be not active, right? So what we're going to do right now is we're going to, and Mark was talking about how you deal with a snapshot and you create versions of the functions, right? So now we have this version 3 and 5, and you can see, right, they're labeled with Snapstart and without Snapstart. So what I'm going to do is I'm going to click on without Snapstart, right? So I'm going to click on this function, on the version, and I'm going to click on a test tab. And the reason why I want to show it in the test tab, because everything is going to be, right now, all we care about, not necessarily invoking it via API gateway or anything else. We just want to look at how long will it take for this function to execute, because right now we assume it's going to be a cold start, which has to take some time, right, Mark?
Yeah.
Okay, so the test data is here. I can basically any type of JSON, because if you remember, the function takes strings, so literally anything will work. So right now I'm just going to click on a test button, and we're going to see how long it's going to take to execute. Okay, Mark, maybe you can explain a little bit about this metrics here that we see.
Yeah, so that screen is showing a cold start, and you can tell it's a cold start by the fact that it has an init duration. So this is the amount of time that it takes to create the execution environment, to load your code into the JVM, and to load any preliminary code. So again, constructors, right, static blocks, any of the Spring functionality, and then duration, which is on the right hand side, is another timing that you want to look at. So the combination of init duration and duration is the total latency of a call.
Right. And if I hit it again, you can see it instantaneous now. So
yeah.
Okay.
Yeah. Which is what you'd expect, milliseconds.
Right. Now I'm going to go back to the one which says the version that says with Snapstart, right? And I'm going to do the same thing. All right, you can see it started much quicker, right? And now Mark can talk about the same numbers here.
Yeah, so it's a slightly different set of numbers. So with a normal cold start, you have an init duration. Here you have a restore duration. So there are two different mechanisms. So we name them separately so that they're easy to distinguish. So this is a restore duration and a duration. So if you are trying this at home after the talk and you're wondering like, why is my function not performance improving, just double check that you are getting a restore duration. That's a really good way of understanding if you are, activating the functionality correctly. So I think here the restore duration is 300 milliseconds, and you have a duration of a similar amount of time. So we've gone from something in the order of 3 seconds to something in the order of 400 milliseconds. So that's a really fantastic performance improvement.
Right, and yeah. So and now I can invoke the same function over HTTP. You can see I passed foobar, it capitalized foobar. So I send HTTP request to AWS, and now I actually invoke this function via HTTP trigger, via HTTP API gateway provided by AWS. So very cool. And now I hope you understand why I didn't want to show you this demo before, because otherwise I would have messed up all this cold start, warm start. Everything would be warm start would be instantaneous, and you would just simply have to trust us. Now you actually see what happened. All right. Oops. Wrong slide. So, Cora, are there any questions?
All right. There are a couple of questions that are more general. So first of all, there is a request to share the GitHub sample link, which I'm sure
absolutely it's coming on the next slide or last slide. Yeah.
Perfect. I'm going to go in reverse order. JR had a question about this is earlier when Mark was talking about AWS in general. What is the best way to make a distinction between cloud compute options let me put the question on the screen actually. Oops. What is the best way to make a distinction between cloud compute options on off-premise compute services?
Can we postpone this question? We like I said, I'm gonna.
Yeah, no problem.
20 minutes. So let's because we have a few more interesting things to go through.
Yeah.
And one of them quite important. So because this question may be the one that we can spend another 5
there's nothing very specific to and then the other question has to do with testing and support for local stack. So we can definitely come back to the questions
cool.
later.
So let me move on because we're about to enter another interesting territory. So I want to make sure we cover it without rushing. So back to Spring Cloud Function. So I hope by now, at least from what you were able to see and digest, that Spring Cloud Function gives you that level of simplicity. You can write function, and all of a sudden this function can become anything, right? There's a caveat though. And the caveat is that at the end of the day, it is still sort of fairly new programming model. And unfortunately, I'm sure that most of the people on the call are not really doing a lot of greenfield development. We're either in the maintenance mode or maybe adding additional feature here and there. So a lot of times we're basically 90% or 80% of our job is supporting existing applications. And if you're a Spring developer, your existing application most likely has something to do with web, because this was sort of was and still is the most popular usage of Spring, the most popular deployment of Spring as a web-based workloads, right? So, while you saw that we can support web-based workload by simply introducing Spring Cloud Function Web as your dependency in the class path, the problem with that is that I constantly get requests for adding more and more additional features. And I raised this question internally. I said, listen, if I start adding more and more features, eventually I will re-implement Spring MVC and Spring REST and everything else, because that's exactly what I would be doing. And that's not, and effectively competing internally within our own framework. This is not what I wanted to do. This is not what we wanted to do. This is not really the goal of Spring Cloud Function, okay? So, but what we wanted to do is, if you think about the web-based workloads, they're, the request response oriented architecture, it really fits well within the functional based model, because request, response, function, input, output. So you can see the similarities here. So, and if you look at this slide, you can see, you already saw the slide before in this deck, but the only thing I substituted is a dispatcher from dispatcher servlet into a function, right? So we're effectively treating dispatcher. So we have a feature now within Spring Cloud Function that allows us to treat dispatcher servlet as a function. And by doing so, you can now deploy AWS. Sorry. You can now take an existing Spring MVC, Spring REST app and literally deploy it on AWS Lambda and interact with it with individual controllers, individual REST endpoints as if they were functions, right? So that's what we're going to show you in a second. So Mark, we'll talk a little bit about how it works in terms of the mechanics, how it will work on AWS Lambda. Just to give you a quick idea, earlier you saw me invoking a real function like uppercase through the dashboard, but you also saw me invoking it via HTTP API gateway by curling to a URL address. And what Mark is going to describe is something sort of similar.
Yeah, so Oleg was describing, deploying a Spring MVC app. So, I'm thinking, how does my programming model work, and how does the infrastructure work when I have a controller with a set of HTTP verbs? So let's just talk through a request. So if we make a request from a customer with a HTTP request, that's going to come into API Gateway, and that HTTP TCP connection is going to basically be managed by API Gateway. And API Gateway is going to send a JSON payload representation of that HTTP request for Lambda to handle. And then Lambda has to work with Spring Cloud Functions to take that JSON payload, which we've seen Oleg demonstrate, and then adapt that to something that your Spring MVC app can understand. And then also on the reverse, send a payload back that can be translated to API Gateway and back to the customer.
Right. So what I'm hearing, Mark, is that there is two parts. One part is sort of AWS specific, which is receive an API, HTTP API gateway request, which is the AWS component, which comes to me in the form of a JSON. And then I have to somehow translate this JSON request to something that is adaptable to a Spring MVC model, which means if I'm dealing with a dispatcher servlet, it has to be something along the lines of HTTP servlet request, HTTP servlet response, correct?
Yeah, exactly.
Right. And that's actually what we're doing. So in fact, I don't want to take all the credit for that, because AWS has Mark, how long you had it? For a year or two or so? You had a
at least,
AWS serverless. Yeah. About 2 years, right?
Yes.
Yeah. So there's a project within AWS called AWS Serverless Java Container, which was specifically designed for that. And at some point of time, you provided support for Spring-based web workloads, and there was issues on the Spring side that you were sort of you were reaching out like, how can we fix this? How can we fix that? So, and this is what the result of this collaboration. We decided, how about we'll take over the like I mentioned earlier, there's two parts. So I said, how about we take over the Spring part and you take over the AWS part, and we'll meet in the middle. So what the result of this collaboration effort is that in the milestone 2 of Spring AWS Serverless Java Container, we are actually having added a native Spring Cloud Function support, where we provided an implementation of a handler which uses AWS libraries to convert what I was saying earlier, convert the JSON request to HTTP servlet request, and then it falls back into the code provided by Spring Cloud Function to do the interaction with the Spring MVC stack. And that interaction is done actually via dispatcher servlet. So, for example, you know that in a typical Spring MVC app, dispatcher servlet is an essential component of the interaction within your web application. Typically, you interact with the server itself, which delegates to HTTP to dispatcher servlet. In this case, we don't start the server. We actually create an instance of a dispatcher servlet, and like I said earlier, we convert the JSON payloads coming in from AWS to HTTP servlet request, and interact with a dispatcher servlet on the API basis, not on the network, not on the network style. So in other words, request comes in to a API gateway. We have a request adapter that translates this request to HTTP servlet request, calls a dispatcher servlet. This part is provided by Spring Cloud Function, and then on the way back, the same request adapter converts HTTP servlet response back to output stream and back to the user. Okay. So, and this is the final demo. So this one actually going to go through the whole SAM deployment and everything. So I'm going to close everything here. We're perfect on timing. So another project within this MVC AWS. So I'm going to quickly show you the code. So the code, like it's a typical Spring MVC app. So we have controllers enable Spring MVC. So here, nothing Spring Cloud Function or AWS specific. You can look at the inputs. So everything is just pure Spring. We have the main object. This is actually cognitive identity filter, which is the for security within AWS, which is out of scope for this discussion. But basically another filter to address the certain security features provided by AWS. And then we have the main objects for model data for the pet store. We have pet object and so on. So like I said, you're kind of a slimmed down version of a typical Spring MVC app, right? And then we have this application, which here we just a Spring Boot application with your main method and everything else. And you see we're adding a filter like so, and a few handlers and so on. So again, some of it, like as you can see from the comments, they're not necessarily necessary, but simplifies things a little bit. The bottom line is that this is your typical Spring MVC app, and that's pretty much it. So again, look at the pump file. You can see that it relies on AWS serverless Java container Spring Boot 3, right? And the template file here, you can see that we provided specific. This is the handler that we provided for AWS, which does exactly what I described in this previous slide, which does effectively the request adapter, which converts request to HTTP servlet request, and on the way back response. Okay,
so it's exactly the same as how Spring Cloud Functions is gaining a capability by adding a dependency. It's the same thing. You've got your Spring MVC app, adding a dependency, and you're creating this new capability. It's fantastic.
So I switched to application, so I'm going to do SAM build. As you can see in my dashboard right now in Lambda, I only have uppercase and the full bar that I created earlier. So SAM finished. So SAM deploy. So this is what you would do with the demo when you execute it at home. So now we just have to go through some of the selections. Like I said, most of them are default. And then we can wait a little bit, but Mark, we can.
So what it's doing now is it's looking through your template, determining what changes need to be made. So it's going to look at your AWS account. It's going to determine that some new things need to be created. And if you were changing an existing template, it would look at what changes needed to be made. And it will work out what needs to be done and then go away and do it. So in this case, probably creating a Lambda function or updating an API gateway. And then it will go through a number of steps until that's complete.
And while it's completing, I also want to show you the class path. So for example, like you saw from the pump file, the only thing I have here is dependency. The only relevant dependency to the discussion I have is this one, which is the AWS serverless Java container. But if you look at what I have here dependencies on Spring Cloud Function serverless web, which is a new module within Spring Cloud Function that was actually released today, and which is used by AWS serverless Java container. So this is a result of our collaboration. And right now, like I said, we split the task in two parts. AWS takes care of translation of the request to and from HTTP, JSON to HTTP, from HTTP to JSON, and we take care of all the interactions within the Spring MVC stack. Okay, so let's look at our deployment. Our deployment is finished. We can go back, refresh the page, and we can see now we have pet store boot 3. And so we can look at it. You can see it actually appears as Lambda with the API gateway attached to it. So now I can go back, and you can see I can actually cut and paste this. Let's say curl, and spell curl. Again, cold start. And now you can see the JSON printed out for all the dogs pets that I have there. So I can do it again. You can see the warm start is much quicker. And yeah, I can execute, hit other REST endpoints and so on and so forth. So, yeah, that's pretty much it. So in summary, Spring Cloud Function model aligns perfectly with Lambda. Again, you saw me starting my demo by saying, okay, here's the function, and I can attach different triggers to it. And then when we presented Lambda, and Mark was describing the inner workings of Lambda, it literally was almost identical. Lambda is out there, as it defines just a piece of functionality, and then you can attach various different triggers to trigger that Lambda to make it useful. Okay. Lambda Snapstart reduces cold starts by up to 10 times. So again, a very nice feature for those who really care about ensuring that the application could be instantaneously started from nothing, from 0 to 100 in a split of a second, right? So again, a lot of people may not care about this because, for example, if you're just simply talking about a simple web app, I mean, 2 seconds of a cold start may not be a big issue. You will just, but for high performance streaming apps, that may be a big deal. And obviously, Lambda AWS provides a solution for that. And
yeah,
now,
there's lots of customers out there who are writing MVC applications with Spring, and they're customer facing, and all that latency is adding to negative customer sentiment. So the more that we can do to reduce latency, the better. So whether you're a very high throughput retail site, or whether you have a number of back office functions, Lambda really fits well. If you have low traffic, then you're not paying for idle capacity, and more importantly today, you're not generating the electricity, and you're not burning carbon. And also, if you have high throughput websites that have variable traffic, Lambda will scale and meet those demands, and then come back down, and you won't overpay for the capacity that you provision.
Perfect. And last but not least, Spring MVC can now be represented as AWS Lambda, and as such run on AWS Lambda. All right. So what's next? We obviously, as you can see, the interesting thing here is that we have, as Mark was saying, we receive HTTP API gateway request, which comes in the form of a JSON. And from there, we're extracting enough information to construct HTTP servlet request, which means that even if you send me a message over Kafka or Rabbit or anything else, and you can provide enough information for me to construct HTTP servlet request, that means that I can actually interact with the MVC app without starting a server. So right now, we don't have anything hardcore in plans. We had a few experiments, but this is as community will demand, as community will start using it. We're open to this type of engineering where we can say, listen, you may not come, because again, in HTTP API gateway situation, you come from HTTP, you go to HTTP. So that's actually match one-to-one, right? But we're open to situations where you may not come from HTTP, but if you convey enough information in your message, I can make an HTTP request for you, right? And support for Webflux, we're still debating internally because Sure, we can support it.
Lambda is effectively single-threaded, so a Lambda function execution environment will only ever execute one request at a time. Right. So it's really nice to simplify the programming model and less things to think about.
Right. I mean, we can support it at the API level. In fact, we do. You can write your function, for example, using function flux, for example. It will work. Make no mistake about it. It gets supported by Spring Cloud Function. But it's only API compatibility. You're not going to enjoy all the features and benefits of reactive because the actual source of data is non-reactive. Okay, and links and resources. So again, there's actually maybe not properly presented, but there's two links here. So this one, it's this one. Well, the first. Oh, I didn't want to do that. All right, so it's this one, and then this. So this one, the last one, Spring AWS 2023. This is the one from which I'm showing you all the demos today. So it contains this repository contains two projects, which is exactly the projects I used today. So I guess those slides are going to be published somewhere, right, Cora? Or
we will.
And then the QR code is for a set of resources for Snapstart. So if you're interested in Snapstart, take a photo of the QR code for later, and that has a number of other examples for using Snapstart, infrastructure as code examples, and also a set of blogs and resources for learning more about how it works.
Okay, thank you guys very much. I don't know if we have time for questions, Cora. I mean, we're open to just top of the hour.
So a couple of questions were about resources. So I think your resources slide hit those. There was just a couple of questions, which is the very general one. Let me put the questions on the board, and then you can decide if you have time or if you'd rather redirect them, because they're not tremendously specific to Spring Cloud Function. But one is JR, who was asking if there's maybe some guidelines in terms of making distinctions between cloud compute options on off-premise compute services. That was one question. And Simon Verhoeven was asking about support for local stack. We do have Edu from Test Container Project who was helping out with that question on YouTube. So you can see the chat there. And really the last comment there was Simon sort of being more specific about thinking more in terms of support in terms of test samples, using it in the documentation, and maybe some convenience methods. So
I'll leave the first question. There's a heap of content on the AWS website. It's a very broad topic, but from the terms of local stack and test container support, yeah, absolutely. I do local testing of my Lambda functions with test containers. It's fantastic. So that's all within possibilities. And yeah, for further resources, so samples, infrastructure as code, testing examples, follow the link I showed. So and that includes a number of different examples plus a number of different blogs on Snapstart.
Amazing. Well, I feel like you just blew my mind with the support for web. And I'm really looking forward to. I assume that'll also feature in your keynote in
that is the feature of the keynote.
Vegas. Perfect. So I very much look forward to that. I want to thank you both for coming. This was a pleasure and amazing work. Congratulations. And I'm sure the collaboration is also fun for you. Yeah. So I have a couple, before we go, I'm just going to quickly tell people I have a couple of things to promote, and then we will sign off. So just before I do that, I'm going to thank you guys, Mark and Oleg, for coming today.
Thank you.
I really appreciate
Thank you.
it.
Bye.
All right, everybody else. So Spring Academy, definitely check that out. It's a free website with all kinds of education about Spring, whether you're new to Spring or have more experience. I'm sure you'll find a lot of value there. If you want to catch the keynote with Mark and Oleg, definitely try to join us in Las Vegas for VMware Explore. That's August 21 to 24. And with that, I look forward to seeing you at the next opportunity. Join us for the next golden path to Spring One. Thanks, everybody.